Hi, thank you for joining for today's session. So talk about, we'll go over. Yeah, if you have any questions somewhere in between, do stop me and ask, and I will try my best to help you with that. In case if I'm not, I will surely get back to you in the next session. Okay, with that we'll start today. So what all is planned for today's session is basically, sorry, yeah, make it week two. So we'll discuss the previous week's assignment solutions, and then we'll talk about one of the sustainable developmental goal number 7, that is sustainable and clean energy. So how clean is the energy that we are using these days, especially in terms of wind energy, so which is also renewable energy. We'll talk a little bit, try to understand how sustainable it is and what ways it can be made, little sustainable. Okay, with that thing, uh, let's start. Just a minute. Just give me a minute. Yes. Yeah, we'll start. So, the first question was matching the categories of chronic effects with the corresponding term. So, what does each of these effects mean? So, teratogenicity, mutagenicity, carcinogenicity. So, the answer is B. So, basically, teratogenicity is related to birth defects, while mutagenicity is related to gene defects, and carcinogenicity is something that causes cancer. So this is a term that we might have heard often: carcinogenic substances or substances that have cancer-causing properties. And mutagenicity, or is the ability to cause mutations in the DNA, or basic or the so we refer to as genes, basically in terms of those DNA sequences that are are passed on or that have some role in the body. So if they get mutated, then it will alter the functions. And teratogenicity is related to birth defects. And coming to the second question, does response curve, sorry, dose response curve are typically influenced by both the duration of exposure and the route through which the exposure occurs, whether it's a true or false. So the statement is true because if you receive the same amount of dose of any substance, let's say for example externally by skin, or if you have inhaled or ingested it, the response you get is different because the some of those components will be far more better at spreading if you are inhale rather than if you are just come in contact through skin. So yes, it is influenced by the duration, uh, sorry, the route at which it is exposed. And as we all know, so the longer you are exposed to anything, the higher the different will be the dose response curve. So the option is true here. And yeah, this dose response curve which we were talking earlier, so here we are asked to label those points A, B, C, D. So lowest observed adverse effect level, lethal dose 50, no observed adverse effect level, derived no effect level. So here we all know that the point D is LD50 or lethal dose 50, where at least 50% of the population that is being tested, is dead. So option D has to be LD50. And option C is LOAEL. So lowest observed adverse effect level. So here at least 20%, somewhere around 20% of the population starts dying. So that's where you have the lowest level. And B is no observed effect. Here, because there is no there isn't any individual or percent of individuals dying here. at the B point, and then A is derived no effect level. So here basically you don't have any effect level at all. Both A and B you don't have any effect at all, but A is a point that happens at that is at much more lower concentrations. So the right combination is the option D. And yeah, fourth question, according to the lecture, so for which you should yeah, what could be the main cause of pollutant transport in Lake Baikal? So if you remember, Lake Baikal is present in, you know, I think it's in the in near to Russia, somewhere around that region. In uh, so what could be the main cause of pollutant transport? So options were the water body has a distinct starting point and ending point, or due to thermocline, due to large currents, or due to water body static overall. So the option is right. Right answer is due to thermocline, because if you remember what is a thermocline, you can think it as, a layer, which separates, warmer water and the colder waters. It's like a straight layer, or it's not. It's an invisible layer, but if you happen to breach that layer, the top part of the layer is, much more warmer, and the below part of the water will be much more colder. And if you have watched or heard of this movie called Meg, where they try to depict this shark called megalodon that has breach happened to breach thermocline, and then which has been extinct for, at least the movie. In the movie, it was it's already it already present, but it's stopped by this thermocline. Once this thermocline is breached by human activities like deep sea drilling, this species comes and wreaks havoc. So that's what is being referred to in the movie also. So if you have heard of it, that's how it is. So what happened here is, because of the thermocline, there is no intermixing of water that happens. So whatever pollutants are added to this hotter waters, they tend to be transported way way long to much longer distances. And the fifth option, so where would the pollutant transport in air be more relatively more, either it is Mumbai or Aurangabad? So I presume Aurangabad is in somewhere in northern India, most likely in UP. I'm not sure about that, but yeah. So assuming we had assumed that same amount of pollutants are present in both places. So what we know about, what's the difference between these two places? If you see, Mumbai is, is a coastal city, and while Aurangabad is not a coastal city. So in places like Mumbai, where there is a relatively higher humidity in the air, the pollutant transport will be relatively higher. So Mumbai is the right answer here. And which method of remediation of contaminated soils has an inherent risk of resuspension of the contaminated sediment in the water above? So if you remember from the lecture, uh, uh, which method of remediation of contaminated soil has an inherent risk of resuspension? So if there is soil that has been contaminated, but it's not been, it's been like that, but what will lead to it resuspension in the water? Let's say, for example, this is a lake, and then we have this soil here that has been contaminated by some, it is contaminated soil. So which of these activities will lead to, it leaking all these contaminants back into the water even after the contamination is stopped? So monitored natural recovery, remedial capping, dredging, or in situ treatment? So dredging is the answer here, because what involves in dredging is you have to, you will dig out all the soil, and then you take it out. So when you have to dig it again, it has the water, the soil gets resuspended into the water. So the remedial capping option is basically you try to, cover this whole area, and then seal off kind of, which might not be possible in some cases. So dredging leads to resuspension. And using silt curtains can increase the risk of pollutant transport to air. It happens because due to diffusion, evaporation, mixing, and condensation. So what happens if you use silt curtains is once the silt is once the water has evaporated, so the silt can when there is a lot of wind that comes up, it will be just transfer it will lift it into the air and then it will spread it out. Going on, which of the following comes under the cost of regulatory compliance? So regulatory compliance is something that industries or some organizations have to do as part of regulating something or regulating their impact in here. So cost of monitoring, cost of environmental damage, cost of image, cost of workforce absence. The right answer is cost of monitoring. So what type of damage the company or the product that it generates causes. So those kind of things will come under you know regulatory compliance. So these are things that companies have to comply with when they are formed or they are given permits to operate. So these are the costs that are involved with that. Each LCA phase involves determining the environmental impact based on input output analysis. So impact assessment is that phase where you determine the environmental impact based on input and output. What all things are going in, what all things are coming out. And going on to the last question, midpoint indicators and endpoint indicators focus on multiple environmental problems and single environmental problems, respectively. So what they are saying is midpoint indicators they focus on multiple and endpoint have just single problems that they are trying to focus on, which is not the right combination. So midpoint is something like basically if you are having a goal or if you're trying to do something, midpoint indicators or something which will tell you where you have reached in achieving that thing. So it's generally it involves lesser problems than endpoints. So so yeah, this is from last week question and answer sessions. Last week assignments.
Hello, sir.
Yeah. Hi, Abrar, do you want to say something? Please go ahead.
Hello, sir.
Yeah.
Sir, can you explain question number 8?
Question number 8.
Yes.
Okay. So, okay. So, if you think about cost of regulatory compliance, let's say there is this company, okay, there is this industry, you know. So, basically, it's the cost of regulatory compliance. So, cost of regulatory compliance is like, it's something, it has to, compliance is like, it has to follow a set of rules, right? So, which of these following comes under the cost of regulatory compliance? So, for it, if you think of cost of image, let's start from one of these. So if you talk about image, it is not something that a company has to especially comply with in terms of regulatory how the company works. Okay, it might be the interest of just the company but not if you take in terms of the rules set laid out by the government. Cost of workforce absence. So if there is no work, so what if the workforce is not present, the people who are working is not present, or if they are absent, so the cost they have to bear if the workforce is absent. So which might not be something that they had to comply with if there is no people are let's say not coming for work. So they might have to shut down for a few days. and it's not like they had to be open all days with this many number of workers. Sometimes the cost of environmental damage. So these two A and B options seem little likely. So let's look a little bit closer on them. So cost of environmental damage versus cost of monitoring. So cost of monitoring is something that you monitor. So the cost that you had to pay as a company to monitor, what you are doing, right? Let's say and cost of environmental damage is the cost that you had to pay for damaging the environment. Okay, let's say for example, industry is being set up by or instead of industry, we can think it of as a they're try there's some in some place someone wants to set up coal mine. So they might have to pay this much amount of if they had to set up, let's say they had to cut 1,000 trees, so each tree has some value, so they had to pay that amount also. Okay, so and then once it is done, so they can just start having the coal mine there. But what for what monitoring is like, you have to continuously monitor that site for whatever things that you are doing damaging, right? So this is what comes under regulatory compliance. So basically how things are working out here. uh yeah, hope that was little better. If you couldn't understand this, I can at the end of this session I can try to we can have a little chat together and then try to solve it little better. Okay, if you understand it, if you understood it by now, that's nice. If you couldn't, but we can again come back to it in the end and try to understand what is what are things that come under regulatory compliance, and then how cost of monitoring is one but not cost of environmental damages. Okay, is that okay, Abrar? Yeah, I take it as yes. And then go ahead. Oh yeah. So affordable and clean energy. So this is one of the sustainable development goals that were discussed in the session one, and this is the number 7. So what does it say is like everyone should be able to have affordable, and then the energy has to be coming from clean sources of energy. So if you look at what proportion of energy we are generating, so we are having exajoules, this much amount of energy, somewhere around 21 we are having somewhere consuming around 400 exajoules of energy in 2021, and much of this energy is coming from fossil fuel based, and only 12.6% is coming from renewable source of energy. Like what all renewable sources? Solar, you know wind energy, the geothermal, hydropower, and then biofuels. Okay, so and then the total amount of energy consumption has also increased across years, and but there is relatively little proportion increase in renewables energy contribution to the whole energy consumption. So which is what the sustainable development goal tries to aim. So reduce the amount of fossil fuels and try to have this renewable energy in higher amounts. And so these are all like this energy consumption. Okay, but this energy sector, hi, someone raised a hand. Is there something that you want to ask? Is something that you would like to ask? Someone raise their hand. No? Okay. Then in that case, I will continue. So each of these energy sector, if you're looking here, this fossil fuels and then hydropower, renewable, biofuels, all these sectors, they themselves are are emitters of carbon, you know, uh, greenhouse gases, especially uh, the oil, fossil fuels, methane, coal, and especially this fossil fuel based energy generation is higher. And then it hasn't changed that much across 2021 and 2022, but there is slight increase. Okay. So and much of this energy, if you remember, is used majorly in building construction, buildings, industry, transport, very little percent in agriculture. So where it is used in buildings, especially it it's not used much in India, but yeah, if you have air conditioned buildings, there you are using you know energy to cool down the temperature of your building. Or if you are in northern regions of the earth, northern latitudes, or in European countries where during winters you have to heat your buildings to keep yourself warm inside. So that's where the energy is consumption is coming from. An industry to build anything you have. Let's say, for example, for you to make steel, all these ingredients of steel has to be heated to certain temperature. For heating to happen, you need energy. For all those processes to happen, you need energy. And then transport. That's where we are using fossil fuels the most for moving around. And agriculture also need energy, especially for instance to transport of goods, or for irrigation, or other things. And if you look here, and most of only 15% or very few parts of the total energy consumed is generated through renewable energy, and especially the transport. If you just look, it's only 4% of the total energy consumption in transport happens is generated through renewable source of energy. But industry and buildings, they relatively have higher proportion. And even in agriculture, especially, at least you might have most of you might have seen in rural India, this value is relatively higher because you have solar powered pumps to irrigate those fields, which has been widely used, or using government schemes. They have encouraged farmers to go for renewable energy sources so that they don't have to depend on free electricity for irrigating their fields. So where all it is coming from? So most of it is, you know it's generated, heat is generated to renewable heat. Fuel, most of the fuel, only 3.7% is generated from biofuel, and 30% of the whole electricity demand is used from renewable electricity. So what all these figures are trying to say is, like, basically the renewable part of the energy that we have been using is very very less, and we are still largely dependent on non-renewable sources of energy that has wide scale climate impacts. uh, Another graph, the contribution of energy, how it has changed across years. The share of, if you look at the share of renewable energy, like especially this sector, it has increased little bit, so 9 percentage points increase. But if you see here, interestingly, the nuclear power, which we were discussing in the last session, has decreased across years. This could be because the total amount of energy production themselves has increased and then nuclear power has remained unchanged, or there are with time some of those nuclear plants has to be decommissioned. So owing to that, that might have happened, or there might be cases with no new nuclear power plants have been installed. So but yeah, the thing is like renewable electricity generation has been increasing, but at a very slow pace. So as we are saying, so the different forms of renewable source of energy. One is a solar, wind, geothermal, hydro, biofuels, heat energy. So yeah. So if let's just have a look at what wind energy is and you know how sustainable in terms of environment and social aspects it is, how sustainable it is, economic, environmentally sustainable this wind generation is current in this current scenario. So we all know what is wind energy is. So you use the power of wind, which is to generate electricity, and it is not a new way. So it has been the oldest way to harvest energy. It's if not used directly for generation of electricity, it has been used for a longer time to to do something else, some one thing or another. And all countries, major part of the countries uh, have wind in some form of another, and wind turbines can be set up offshore or on land. So what does that mean? So wind farms, they can be on the mainland, like what we generally see, and there can be offshore wind farms. So basically you have wind farms set up just from the few, yeah, within some kilometers of the shore, because that's where you get large amounts of wind. And then you're also the difference between these and this is you don't have to worry much about the land, getting the land here to put up set up wind farms in the if it's in the ocean, because you don't most of us don't have this is our part of land and you can't access it, kind of thing. But if it's mainland, you might have to have people residing in those areas. You might have to ask them to sell their land, or rent out their or lease out their land, so that the company whichever is operating can set up these wind farms, so which might not be the case on the offshore. There might be some advantages also, but yeah, let's go ahead. So what's the wind power capacity? It's like in the global scale. So from 2012 to 2022, somewhere around currently we have somewhere around 906 gigawatts capacity. Uh, uh, Hi, I can speak Hindi, but I don't want to hear because there are a lot of others who might be from other regions and might not be able to understand Hindi. So I'm sorry, I can't speak Hindi currently, but yeah, if you want me to explain a specific one or two things so that you can relate it better, I can just explain that term again in Hindi, but I will be using English as a major language so that people from other regions can also understand them. Oh, yeah. So yeah, there is 906, somewhere around 906 gigawatts of total energy capacity in the world, uh, and it has been increasing at a slow pace. It's not that rapid enough to meet to help us go out into all mm, renewable energy sources to support our energy demands. And if you look at the wind power capacity in additions, so the brown bars are added. So basically China and United States have been dominating these, getting using this wind power to generate. their electrical needs, especially China is topping it up. It's somewhere around 350 to 380 gigawatts it's generating per year. But if you see the rest of the world, it's coming close to 160 gigawatts, and then India managed to add 1.8 gigawatts capacity in the past 1 year. And in some places, some of the farms might be old, so they had to be decommissioned, so the net increase is very less in some places, but the amount of it being generated is relatively you know less in like other parts of the world compared to United States and China. So let's try to look at how sustainable is wind energy. So you can view it through the energy itself. We can view it in we can think it of two different aspects. How sustainable is the generation of energy itself, and then the subsequent environmental impacts of the wind farms and thus the generated energy. So let's first look at the energy itself. So if you look at energy, so some of the things that really create a problem is the technology and the skill. So to make up to build these windmills, so you need all those equipment, right? So the technology is not present in all the places. Let's say, for instance, countries like India or Brazil, which were showing very high, higher amount of greater increase in their addition of wind energy capacity. So there might be they're just importing the technology from other countries which have managed to master the art of developing these windmills, which 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 will eventually hinder the process of generating the energy itself, because sometimes the budget or the amount of the equipment you can import will be limited by a number of things. So if the technology can be transferred from these to these nations, then they can have uh, they can help increase the generation very much. And the other problem that comes with energy generation is the storage itself. So sometimes we will not be able to have storage capacity. So everything, whatever is generated, has to be transmitted. But whatever is transmitted might be, you might end up generating sometimes when there is higher amount of wind that is coming to those areas. You might be ending up generating lot of electricity than what the demand is. So you need to should be able to try to store that, and then reuse that energy when the demand increases than what the windmill can generate at that point. So the storage technologies are also are improving these days, but still the same thing has as generation is a problem here, because it has to be transported or it has to be shared across. And the third thing that comes is the transmitting of this energy that is generated here. Because if you have seen or experienced watch some of these photos, or just let's talk about this photo itself. So where is this windmill located? It's close to a coast. But if you see, there are hardly any you know houses, homes, or industries that can utilize that electricity. And then this is the case in most of these you know wind energy wind farms, because they are generated in these remote places, mostly remote places, and then they had to be transmitted from that location to these distant places where the townships or industrial areas are. So transmitting of energy is huge thing. For that you have to you have to build up new power lines, power grids, or you have to upgrade your older power grids so that you can send this energy across, which itself is, takes a lot of time and skill. And it also, costs a lot, cost and finance, to be able to, differentiate, like how much is the, how much the party that is planning to install these farms is willing to pay for, for all this, like the generation cost or the transmitting cost or importing those technology. So whatever the cost associated, so they are relatively higher. So that also, pushes back a little bit on how well, you know things can adapt into getting those things. Similarly, geography and land use, so these are really important aspects. So where can you put a wind farm? So you can't just go and randomly put in any other places. It has to be a place where you get, minimum amount of wind speed. So without the minimum wind speed, there is, no use of having large scale wind farms running around. So the geography is important, and wherever you find this area, it's not necessarily you can just go and set down. Sometimes those areas, are present in protected areas, forests, which you obviously cannot get permission in most cases. Even if you get the permission, you have to, pay for the cost of cutting down those trees to the government so that, you can do that. Or in some cases, it has to be, agricultural fields, fertile lands, or it has to be, or it is human dominated areas where you have to negotiate with the people that are staying there to, saying that we want to set up a energy farm here, wind farm here, so would like to buy your land or lease your land. So all these, things try to push this thing little back, but still, there are a lot of wind farms that have come up in India also. And let's have a look at the environmental impacts a little bit. So we all know that, it's not really clean. Wind energy is not that clean as such, because, these are really tall structures which you can see. If you have seen, you might remember. So it impacts a lot of, it has different impacts. If you talk, let's talk about local vegetation. So for the construction of a windmill, you can't just take this windmill onto the let's say this hill, and then, airdrop the windmill and say, and then start construction from it. So it's not possible because they are so heavy structures. And then each, for instance, if you watch some photos or videos, there will be huge, uh, trucks carrying these, with trailers carrying, one truck will be carrying, just one of these fans, one of these blades. So this will be such a huge thing. So for it, they can't just carry it to any randomly, right? So for them, they have to construct roads, cut down slopes, especially if you are trying to make a wind farm on top of a hill. Like if you are seen, uh, in Nashik, Nashik, if you're from Nashik, you might have seen some wind farms there that are, made up on the hill slopes. So for there, you had to make roads to for these vehicles to go. And then once the roads are made, you had to, get all those stuff up, all those equipment up, and then start the construction. So during the construction phase, especially, the local vegetation will be impacted. Since you are clearing it up, it might, bring in invasive species, it may remove some native species, it will change the way the landscape looks. But but the good thing is, this local vegetation change happens only, mostly is for the happens during the construction phase itself. Once the construction phase is done, uh, the things will, and then there is no more, disturbance happening. So the local vegetation will try to move back to its earlier state. Flora and fauna, which this is thing that we might have heard a lot, especially the avifauna, birds, getting impacted by windmills, which is we have seen a lot. And mostly is like windmill collisions and then deaths. So we'll come back to it little later. And the other thing, apart from vegetation and flora and fauna, the other thing that we ourselves don't like is the noise that these wind farms generate. They are not quiet, right? Really. So there is two different types of noise that can be generated because of these wind farms. One is this aerodynamic noise. It's when the wind flows through these turbines. There's this airflow that is generated, and then that creates a howling type of noise. So that is what aerodynamic noise is. And then there is this mechanical noise. So because there is turbines associated, and then the gears and levers that are present inside. So that moving of those parts, they themselves can generate lot of noise. So yeah, each of them, at least the mechanical noise can be reduced by having proper insulation of during the construction or design phase itself. But aerodynamic noise is something that you cannot really avoid in most cases. And then there is this visual impact. It changes the appearance of the landscape, which a lot of people really don't like. Because if you see a nice landscape, all these hills around, and then suddenly you see from the distance 20, 30 steel pipes coming up, you know generating electricity. It just changes the how the way you view the landscape. It's modified. And then there is this thing called disco effect or shadow flickers. So for instance, if the sun is in the backdrop, let's say the sun is here, and then if you're watching it from here, and then the wind turbine is rotating this way, so it will create a flicker. uh, the best way to think it of as is, let's say for instance, in your house, if there is a fan just below the light, so if the fan rotates, it causes a flicker, and then it really irritates a lot of people. So those type of effects are also there. And then it depends on the angle of the sun. And then this is electromagnetic interference. So because of the way wind turbines work, it can also lead to a lot of electromagnetic interference in the nearby regions, like radio signals. So let's look at a little bit more in depth about how it impacts local climate. So how wind will impact local climate. So uh, let's talk about wind itself. So for instance, in most areas, the wind brings with it a lot of different things. Like for instance, if you are in a coastal area, the wind will bring it with it a lot of humid air or moist air that will go further inland and can have other impacts. So but if you are putting up these windmills, the wind that is coming, it will rotate the windmills, and then the momentum is transferred from the wind to the turbines, and then you get electricity. But the air is losing that momentum, which could have uh, which will eventually disturb the natural exchanges of energy between the land surface and the air or the atmosphere that happens. Let's say for instance, let's think the wind that is coming from here comes here, and then it will cool down this area by taking the warm, warmth of the ground and cool, cools down the area. But now since there are wind farms, you know the energy is transferred just to these windmills, and then it's not cooled down, and then these areas have larger higher temperatures. So that's what some few studies have found. It's like at least there's this one study from China that has found local temperatures increased by at least 0.72 degrees. And they have found a higher nighttime temperatures also, where little away from the wind farms, or the downward side of wind farms. Let's say, for instance, the wind comes from this side. So this side. So if there is a landscape here, So this will be called as downward side, because windmills are coming in between and the wind energy is coming this way. So this will be the downward region. And then it has been observed in other places also. And then there's this interesting study that model if this thing happens and then we end up getting at least 10% of the global energy demand by just by windmills. They found out that they model that the global temperature will increase by 1 degree Celsius just because of this effect. Because you're transferring the way this, you're taking out the momentum out of the air, and then you're not letting it do what it generally has been doing to to these areas. So you might see at least 1 degree Celsius increase in temperature by 2100. So there were other models that say this might not be the case also. And then not all, so it's not just the negative effects of on local climate, it can also have positive effects on the local climate. Like in this another study from China itself, they found out that you know presence of these wind form wind yeah wind farms, it reduces the local wind speed, which we are talking about being a problem. As this reduction of wind speed in that area reduces the chances of sandstorms, because the much of the energy is taken up from the wind itself by the wind farms. So yeah, so choosing a location to set up a windmill is really really important. And now now there are this where people try to understand, they have these computer simulations like which areas might be best because of the air flows. And then now there's this other thing also that has been incorporated, like how it might alter climate, how it might affect wildlife also. So it is really important to to understand that it affects local climate, which which we generally really don't think it can alter. But a small scale 2 3 windmills might not have much effect, but large scale wind farms will show these type of effects. So how do they affect vegetation and wildlife? So other thing that these can do is, especially during the construction phase, it will lead to lot of soil erosion. It can lead to fragmentation of forests, because if you are going into forest for pristine areas, you have to cut through those forests, and then this will lead to fragmentation. And then along with that, if the slopes are eroded, soil erosion has happened, and it will change the hydrology of of the landscape itself. Some places might have altered hydrological system, like there'll be increase in water flow or decrease in water flow from certain regions, or drying up of some local streams, because you have altered the hydrological features of those areas. These things are happen especially in the construction phase, but sometimes these things are you know are seen even after the construction has been stopped. And I, I beg your pardon for spelling mistake. It's risk. Especially there is if you talk about wildlife, the major risk is especially for flying, the wildlife that can fly, especially birds and bats. Like these are the organisms that can fly in these open landscapes. And then most of these wind farms are present in open landscapes, like it's open as far as you can see, at least if you go a little higher. And it's also a major risk for birds that migrate. And so how does it affect wildlife? So they can affect wildlife directly by collisions. These birds, when they are flying, since they have been taking these paths for longer time, or it might be easy path for them to follow, they can just directly collide with the windmills and die. And sometimes what happens is, because uh, since these windmills rotates, you know let me just draw it and try to show you. So let's say if there is a windmill here, let's say windmill, So when it rotates, let's say it rotates this way. So what happens is, it creates a vortex that goes on like this. Okay, it creates a vortex that sucks in air. Okay, if you've seen some videos of burning windmills, you can see these loops that forms continuously of smoke. Okay, so what happens with that is, smaller birds, especially there are these smaller birds, like swift swallows, that fly on these open areas, sometimes close to human habitations. So, or other birds also, they get sucked up into these, you know the, this air that is that is funneling down this whirlpool of air. And then, since birds have these bones that are lighter in weight, they can break up much more easily. And then they can, yeah, they're dead. Once their bones are broken, they hardly can fly. So they will fall down from that height. That fall can also kill those birds. So that can, even if it doesn't have directly impacting with the wind farm, this the turbulence of air that is being generated from the wind farm can itself lead to that mortality. So yeah, let's go a little ahead. And then some of the indirect effects could be, it's such a nice area, it has been, let's say for example, uh, this is a wetland. And wetland is basically a water body where some of the, you can see a lot of bird species. So this has been a place where they come every time, or every, some wintering birds come here after migration. But because of these wind farms and collisions, they can all right, it's like this is not a nice place to come, because there's a lot of, we had to manure, you have to avoid all these obstacles, we'll just stop coming to this place. So they might just avoid those places. And then, because they are displaced from those places, they try to move to places where they can find there are no wind farms. Even this habitat is such a nice habitat, but thanks to these wind farms, they had to shift to a new place. And then there is this habitat disruption. So a continuous habitat is broken down into multiple habitats. Like smaller birds may not be able to go go around to other places, because this habitat is broken down by these giant structures. And so not every bird is at risk. At least the smaller birds that fly near to the ground might not be at great risk of collision, but they can be at the risk of indirect effects. But the direct effect, birds that are affected are poor flyer birds, birds that are that can't fly, with that have smaller maneuverability, they can't really change the directions quickly. Some such birds, or heavy birds such as cranes, bustards, or birds that have that don't have vision, straight vision, they have peripheral vision, or birds that can see, they can't see greatly in front, but they can see much high greatly sideways. So, or the birds that fly in flocks are the birds that are are at greater risks at the wind farms. Because for instance, let's talk about birds that fly in flocks. If they're flying the flock, they will be following a bird that is that's just in front of them. They hardly get to see sometimes, when the bird that is flying in the front just generally suddenly dives down or flies up. This bird, which sees it at the last moment, might not have enough time to react, and then they might just end up colliding and then dying out. And especially the bigger problem with migrant birds is, they have been following these fixed paths to come go from area A to area B during the winter for thousands of years. Now, out of the blue, if there is a wind farm that has come up, they can't just take a detour and go. Th- that route has been somehow hardwired into their daily lives, so they have to follow those specific paths. They might adapt to avoid them, but it might not happen as quickly as we can think of before the damage of windmills on the population has been done. So that's why especially they have migrating birds are heavily impacted because of these windmills. I, and in general, migrating birds that are larger in sizes. So yeah, there are a lot of mortality that happens because of this wind farm collision, as you can see in this picture on the left bottom corner. So there is also social and economic aspects to it. Let's say for example, if you're talking about land acquisition, sometimes the land is just grabbed upon. In some cases, proper settlement happens with the people who own the land for setting up these plants. So there is this huge social injustice that happens in some cases. It may not happen with wind energy if it's not in, but in some cases, especially with when you had to set up large scale farms, this is what happens. And then some of these farms are set up by private sectors also, with the aid of some government, with aid from government. So the so that will might not have beneficial that much beneficial impact on what the the communities are expecting it to be. And then there is also a negative perception or a perception differences that happen that comes with society, is like that these things are not economically viable. And then they have some effects, like the effect that we're discussing, like if a solar farm is coming next to my house, I will oppose, because I might have this perception that these create a lot of noise, this will kill birds if it is there, so we don't have much economic you know growth. We don't have any advantage of having them here, so we'll say outright no to these wind farms. So we, we need to to take up to these perceptions and provide them. So these are the things that generally comes up with having these wind farms. So this is what we're trying to do. This is the positive effects what you can have. These are the some negative aspects of having these wind farms. So which can help accept, change the perception, and then help accept these type of things into the society. But still there are a lot of issues that comes with it. So for us to be able to make this green energy much more sustainable, these are some of the things that we should really be concentrating upon. Like you had to have these societal and economical aspects addressed, like social justice delivered. When you are at least trying to get land acquisition, you have to properly have a deal where everyone is satisfied. The people whose land we are trying to acquire for setting up these farms, proper compensation has been paid out, or the perception, or they are willing to accept them on their lands. And similarly, there are enough measures to mitigate these impacts on wildlife and vegetation. Like for instance, the some of the guidelines that are are in place these days for when you are installing setting up wind farms, is we can't set up wind farms near to important bird areas like this wetland. If they had to set up a new wind farm in a parallel world without this wind farm, currently they will not allow. There will be no permission given for setting up this wind farm, because these are migratory species that that use this route regularly, and then this wetland for the stopover or for the wintering, which presence of wind farm greatly affects. So you can't really have them. So there's this incorporation of wildlife aspect angle into where all the wind farms can be set up with. And then there are these bird deterrents that have been set up so that birds in total avoids those areas. Like you can have playback speakers playing noises whenever they detect a bird, or if you want to deter bats, you can have speakers that emit high frequencies, which the bats can hear and then say this is something that area that I need not to go to. Or you can have a system where where the system, if it detects huge amount of birds migrating to that area, it can automatically stop the windmills from rotating, or arrest the movement of windmills, so that these things can pass till these flocks that are migrating can pass, and then you can again start the process over again. And then simultaneously, you should be able to reduce the impact that you have locally, especially during the construction phase, because that's the phase that the impact that you have during the construction phase will determine how what all effects it will have in the future, whether that area will bounce back, or it will have an altered, it will be a completely modified landscape. And simultaneously you have to address some of these issues that we have discussed about, and then these energy impacts also, like the thing that we are discussing initially. So you have to address the environmental, social, and then the energy related impacts, which after which you know then only you would be able to achieve this as a clean form of energy. And then yeah, you have to reduce the emissions that are caused during this process, especially construction, transportation. So all these also have to be addressed. Then only you can really, then only we can achieve clean wind energy. And then yeah, till then the wind energy is it's not really clean. It is renewable, but it's not really clean because it has all these issues with it. For it has to be clean, we need to address some of these issues that we have been just we was trying to point out. And this is not an exhaustive list. This is just some of the list which I could get my hands on. That if you are interested to learn more, then you can always go ahead and then search for it. It's not an entire list. Yeah. So yeah, that's all I have here. So if anybody wants to add anything into this, please feel free to you know ask, or we can discuss for a while. Any ideas or any other things that you would like to point out I might have missed, or any other perspective that you would like to add here, so that others can learn. uh, is there anybody who would like to add anything about wind energy, or some of the other angles that we have been discussing about the societal, wildlife, or climate related aspects of wind energy, or energy in general? Anybody has anything? So I can wait for a minute or so if anybody wants to. If you want to, if you're not willing to speak up, you can always write in the chat box. I can read it and get back to you. Or if you have any questions, or any clarifications that are necessary from some of those lecture sessions, do let me know. I can try to discuss in the next few couple of minutes. Uh, okay. It seems like no one has anything to add or ask. In which case, we can we can stop here. Yeah. So yeah, thank you for joining. And this is the end of the class that I had planned of. Yeah. Thank you. And I would like to ask, someone has asked the question earlier. So, are you satisfied with the answer that explanation which I provided for the eighth question? If you are not satisfied, do let me know. I can take a couple of minutes and then try to help you understand it better. So, if you are not able to understand, if you could not understand it, let me know. I can try to explain. If you understood it, yeah, you can let me know. Or if there is no answer, I can presume that you understood, and then we can stop. You can,
Hello, sir.
yeah.
Sir, can you explain question number one, two, three? I was not present at that time.
Okay, sure. I will go through one, two, three again. So yes, the first question was, you know we had to we match the chronic effects with the term. So the chronic effects are one that are given with 1, 2, 3, 4, and the term is ABC. So let's start with what we know of generally. Uh, you know, we might have heard this term carcinogenicity is something that is related to cancer, or a substance that is carcinogenic is a substance that causes cancer. So we will say carcinogenic is causing cancer. And coming to mutagenicity is ability to mutate. So what does it mutate? It mutates, especially it affects the DNA. And here it's the genes that is what we are mostly concerned about. So mutations or the mutagenicity of a substance affects leads to gene defects. Okay. And so let's have a look with this combination, C being 1 and B being 3. So we have the answer is B. And then the other third term, teratogenicity, refers to having birth defects. So defects that are developed during birth because of some other environmental factors, or some factors that have been affecting the mother of the child. So those things are referred to as teratogenicity or teratogenic substances. Okay. Uh, Going to the second question. So if you remember, the dose response curve is basically you draw a curve on the dose of whatever you are looking at, the dose of certain amount of carcinogenic substance or chemical or anything, and then the percent of population that has died, proportion of population died. Okay, let's say this is 50 mark, 50%, and this is 100%. So if you draw a line, so you will get somewhere like some line like this. So okay, so at some doses you don't have any population dying, and it rises till some point, and after a certain amount of dose, however the higher the dose is, you will get all of them die. So this is what a dose response curve looks like. So so the statement was, dose response curves are typically influenced by the duration of exposure and the route through which exposure occurs. So let's talk about the route through which exposure occurs. So route is basically how someone is exposed to that substance. If you talk about a substance, let's say some chemical, if the chemical is inhaled or ingested, it can have certain type of effect. Or the chemical comes in contact with skin or of your hand, it can have other type of effects. Or basically it can shift the dose response curve. Basically a chemical, 5 grams of some chemical, if you ingest it, it can spread across the body at much faster rate, and then can influence no uh, influ- influence the dose response. But if you put the same amount of 5 milligrams or 5 grams on the hand or the skin, it may not, all of it might not get go into the skin, or it will go through a different pathway, and then it will have, the dose curve might shift like this. At higher doses only on skin you will have, you know deaths. So 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 this statement is saying that dose response curve depends on how the dose occurs. And the second thing, duration of exposure. So how long you are exposed also affects. So if you are exposed, let's say if you're talking about radiation, if you are exposed to longer amount of radiation, your dose response curve will change. If you are exposed for shorter amounts of radiation exposure, if you're exposed for shorter amounts of time, your response curve also changes. So the right answer was true. So both of the statements are true, because you will see a shift in the response curve with the duration of exposure and the way that exposure occurs. Okay, and coming back to, say, it's the third was also based on dose response curve. So we have different descriptors. So we define different points in the dose response curve using different you know things. So we have to try and match each of them. So if you look here, we have lowest observed adverse effect level. So lowest observed adverse effect level. So lowest, so which is the level where you have the lowest, at least few individuals in the population start to have adverse effects on them. And then lethal dose 50. Okay, or basically place where 50% of the population dies. Is, yeah, the dose is lethal for at least 50% of the population. No observed adverse effect level. So there is no observed adverse effect level, and there is derived no effect level. Okay, so let's talk about lethal dose 50, which is the easiest one to do. So lethal dose 50 is where 50% of the individuals die. So which of these points suggest 50% of individual die? So this point, right? 50% of the individuals are dying. So the dose at which this happens is D. So D has to be LD50. So it just goes off. Okay. And then the second thing, let's talk about this point C. Okay. So here few individuals are dying. Few individuals are affecting adversely, but it's not like lot of individuals, it's just few. So that will be lowest observed adverse effect level. Okay. This is the C option. So this also has gone, this also has gone. So the remaining option is D. So let's talk about those 2 points also. The point B is NOAEL, no observed adverse effect level. So you have not observed any adverse effect level at this point. So where you are, having some certain dose which is not normal for the organism to have, or higher for the organism, but still you are not seeing any response, no adverse effect in the organisms, and there is no derived no effect level. So here at point A, you don't have, you also don't have any effect there, but it's by inherent property of the organism you don't have that effect. So the right answer is D. Okay. Uh, Hope this was clear, right? And anybody, if you have any other things, do let me know. I can try to accommodate some of those questions. Okay. Then, in case if no one has any questions or any points to discuss or any clarifications, we'll stop here. And yeah, we'll stop here. That's it for today's session. Thank you. Thank you for joining. Hope you get to learn something out of this session. Yeah, that's the end of this today's session. Thank you. You can
sir.
leave. Yeah. So, sorry, someone is asking something. If you have anything, yeah, speak up. I think you are muted, Abra. I think you are muted.
Thank you, sir. Thanks a lot.
Yeah, you're welcome. Yeah, thank you. We'll stop here.